Hey Geometry, I'm still in Unit 6, Lesson 3, Types of Transformations. This lesson in general is stuff that we've talked about when we first started talking about triangles and congruent and similar triangles. So we're just applying this a little bit further using coordinate geometry. So let's get started. Point B was transformed using the coordinate rule. Xy goes to 3x times 3y. Add these auxiliary points and lines to create two right triangles. First we're going to label origin P, and then plot points M and N. Now let's go ahead and draw segments P, B prime. That wasn't very good. MB and NB. So I'm going to connect these points and those points. Okay, I totally realize this is much more challenging since you do not have your classwork printed out in a nice binder like we normally do. I want to remind you that all of these are accessible on the link or through the link that I put in Google Classroom, the illustrative mathematics geometry. It's actually pronounced illustrative. I don't want you to print them out, but they're there for you. I mean, you can print them out if you want to. It's just a ton of paper. Okay. Now, I'm going to now go to the next slide, which we're going to lose this. So let's see what's going next. So I copied what we made on the previous slide, and now we can look at the rest of the questions. How do triangles PMB and PNB prime compare? How do you know? So we learned when we did our triangle similarity unit that I can say these are similar because of the side angle side similarity theorem. All that means are my two angles are congruent, but my sides are proportional. So I'm going to compare PM and PN. 6 over 2, that's PN over PM. That's 3. And then I want to compare the other side of that right triangle, which is BM. Actually, we're going to do BN over BM, which BN is 1, 2, 3, 4, 5, 6, 7, 8, 9 over 3, which is also 3. So when my sides are proportional and my angles are congruent, then I know that the triangles are similar. Okay, what must be true about the ratio PB to PB prime? That's also going to be a 1 to 3 ratio. Okay, what else do I need to tell you? I think that's it. Okay, we do know this is a dilation, a factor of 3, with the origin being the center. All right, match each image to its rule. Then, for each rule, decide whether it takes the original figure to a congruent figure, a similar figure, or neither, and explain or show your reasoning. All right, if I look at A, looks like my pre-image is R and my image is R prime, and that looks like a rotation. Okay, I'm guessing that it's a rotation clockwise, 90 degrees, because it goes from quadrant 1 to quadrant 4. Okay, so let's keep that in mind. Well, it looks like option B did not copy over, did it? That's pretty funny. Right, I found the picture. Surprise, there it is. Looks like this one I have reflected it over the y-axis. Oops. reflected it over the y-axis, and dilated it. Okay, and it just looks like I dilated the x variable. So maybe the y or the x variable went from negative x to positive x, and then I dilated the x. That's going to have a number in front of it. Okay, so let's think about that. And then C looks like just a, so I went from the image f to the preimage f to the image f prime. Looks like a translation, so I want that addition and subtraction one. So that's where we go from x, y, to x plus or minus a number, y plus or minus a number. And then this one, it looks like my xy is going to a dilation, a number in front of the x and a number in front of the y. So let's try to match them. C is going to be kind of simple. It's the only one that has addition and subtraction. D, there's only one of them that changes from f to f prime, where I'm cutting it in half, so I'm getting smaller. Looks like it's dilating the same for the x and the y coordinate, so those are good. So letter B, I know when I reflect something over the y-axis, my x coordinate goes from, for here it's going to go from a negative x to a positive x, but it's just the opposite sign. So I'm going to have x comma y going to negative x comma y. Not that I'm making them negative when I do my transformation, I just want the opposite sign. So I'm not saying it's a negative x, I'm saying it's the opposite of whatever sign there is. And we said that we're dilating our image by a factor, and 3 is the only one that does that. Okay, so we're reflecting over the y-axis, which means my x coordinate goes opposite sign, and our x coordinate is also stretching, getting bigger. So that's where that -3 comes in. Okay, last but not least, I have letter A, where when I rotate clockwise 90 degrees, we change our x, y coordinates to a y -x coordinate. Okay, so the coordinates flip-flop and change signs, and that's something that we will recognize. I always find this one is the hardest for me to remember and figure out, so I have to work a lot harder to remember it. All right, let's write rules. I find these to be a little bit challenging, so let's see if we can figure a way out to make it a little bit easier. So let's write a rule that will transform triangle ABC to triangle A prime, B prime, C prime. So as we look through this, let's just look at the corresponding sides. If I look at CB and C prime, B prime, they don't change. So the length of CB and C prime, B prime don't change. Okay, they move, but they've not changed in length. And that is usually an x measurement, an x-axis measurement. Okay, now if we look at, let's change colors, AC and A prime, C prime, it looks like we're going, it gets larger. So those corresponding sides change, those corresponding sides change in length. So that gets larger, all right? And the diagonal AB and A prime, B prime looks to be getting a little larger too. AB and A prime, B prime. So from this point, to me, just gut feel, it looks as though our x values, okay, our x values, because our x-axis aren't changing because CB and C prime B prime are congruent. Okay, they have the same length. They don't change in measurements. But it looks like there's something going on in the y coordinate measurement. So I find that before, as I practice doing this, it makes best sense for me to go ahead and compare ordered pairs. If we look at point AB, it is over 2 up 3, B is over 5 up 4, and C is over 3 up 4. Now let's compare it to A prime. Like, what's going on? How did A prime change from A? Looks like 2, 6. B prime would be 5, 8. And C prime is 3, 8. Well, how did it change? It looks like all of our y values have doubled and our x values did not. That means that my rule is xy goes to x comma 2y. All right. Number 2 says, are ABC and A prime, B prime, C prime congruent? No, not congruent. Okay, our angles are not equal. We have no equal angles just by looking at them. And I always tell you guys, don't make geometric judgment calls by looks. But our sides are also not proportional because the length of CB and C prime, B prime don't change. Even though A, C, and A prime, C prime, and A, B, and A prime, B prime do change, CB and C prime, B prime also need to change in the same ratio, and they don't. So not congruent. Are they similar? Okay, what do you think? Okay, no. I don't have congruent angles, therefore similar sides. It's the same explanation I actually gave for no congruence. So I apologize for that. Okay, not congruent, not similar. I have no congruence theorems to prove they're congruent. Side, 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 angle, etc. And I have no similarity theorems to prove that they're similar. Okay, so neither one works. Okay, last slide. Now we're trying to write a rule that will transform DEF to D prime, E prime, F prime. Okay, so we're going, it looks like I've just flipped it over the x-axis, which means all of my x variables are going to be the same and my y variables are going to change. Okay, let's do the same thing we did before. So D, E, F. I'm pretty sure this is going to be my rule. But let's check. So D is -2, 1. E, -4, 3. And F, -6, 1. D prime, -2, -1. E prime, -4, -3. And F prime, -6, -1. So it looks like all of the y values have gone opposite sign and all the x values have not changed. Okay, are these congruent? Yes, they are congruent because all sides are congruent. We did not multiply anything, and all angles are congruent. A reflection is, hold on, let me write this, congruent. And most importantly, we learned that a reflection is rigid motion. Therefore, they're congruent. Okay, good job. That's actually it. Okay, it's it for this lesson. Nice work.